So for technique number 3, first want to illustrate the definition of a quadratic equation. Okay, we had a definition of a linear equation earlier. So now, like I said, primarily today we're going to be working with quadratics. Okay, ax squared plus bx plus c equals 0. Okay, and we've discussed already how to solve that using graphing and how to use factoring to solve. Okay, and now we're going to use another technique which we call extracting square roots. Okay, so we're going to see a couple of examples here of extracting square roots. Okay, they are going to be used in an equation like 9x squared equals 27, for instance. Okay, so I would especially use this technique when there's no x term. Okay, you'll notice that there's no x term here. So this is a technique that we'll use when we have that situation. And what we want to do for that is to get the x squared alone. So in this particular case, we would divide by 9 and get x squared equals 3. And then from there, to solve this equation to get rid of the square, okay, we need to take the square root. So ultimately, we're going to get the square root of 3 as our answer. However, one important part of extracting the square root is to remember that there are 2 possible answers that could make this sentence true. Okay, and they are plus and minus radical 3. Okay, so if I did square root of 3 or negative square root of 3 and put them back into the original sentence, okay, they would both make that sentence true. Okay, and if you only had one answer here, okay, that wouldn't be right, because keep in mind, if I were to graph this, how many intersection points would I see? I'd see 2. So if you only get one answer, then we're only halfway done, then, aren't we? Okay. All right. Another typical type of quadratic equation where we use this extracting the square roots technique is one like the following. Okay. Where we have the square on some kind of binomial. Okay. This is another technique where I would use extracting the square root. Now there are other options here. We could FOIL this out and then get everything on the same side and then try to use factoring or graphing. Okay. That is an option, but I'm going to tell you right now that it's quicker and easier to do extracting the square root, which means get the squared part alone. So we'll divide by 2 here to get that alone, and then we'll take the square root of both sides. Okay. And that's also okay in this case when we have that stuff in parentheses and it's all squared. So that would leave me with x minus 5. Over here, it would leave me with the square root of 17 halves. Okay. All right. And then from there, I would add 5 to both sides, and I'd have 5 plus and minus the square root of 17 halves. Now, we got one issue with this answer that we need to clean up, though. Okay, that is the right answer, but it's not in the right form. Because if you remember from algebra, it's not okay to have a square root on the bottom of a fraction. True? So therefore, when we separate that into radical 17 and radical 2, one of our properties of square roots, we need to rationalize the denominator, which means we need to multiply it by itself so we can get rid of the square root on the bottom. And so on the top we'd have the square root of 34, and on the bottom we'd have a 2, and that will be our final answer. It will look something like that. Alright, now checking out that answer, not a real pretty answer, it's got square roots involved with it. Okay, knowing that it has square roots involved with it, had I FOILed this out and distributed and got everything on the same side, okay, it wouldn't have been factorable, so factoring wouldn't even have been an option. Okay, there is another algebraic option that we'll study tomorrow, okay, but ultimately in this case, if you recognize that you have something squared, okay, in parentheses, or like we had up here, just the x squared and no x, okay, I would use always this technique of extracting the square root. Okay, this method is much quicker and easier than doing it the other way that I mentioned. Okay, sure.
How come you don't put the square root over the x minus 5?
Where am I looking? Right here, you mean?
Like the one below it.
Because when we took the square root of that side, the square and the square root cancel each other out. That's the whole purpose of doing the square root, so we can get rid of the square. No, because those two undo each other. If I square something and then I take the square root, then we're back to what we started with. So, good question. Okay. But yeah, once I square that, and again, that's why we take the square root, is so we can get rid of that. We want that to be gone. Okay. So we ultimately have x minus 5 here. Okay, and square root of the right side. And you'll notice what I also remember to do here, that sometimes people forget. Okay, we've got to make sure when we do this that we get two answers here, plus and minus. Okay. Questions so far?